All right, we are going to do part 4 of programming concepts in JavaScript. Here we'll do if, for, and while, which will all use Boolean expressions. All right, let's start with some examples. So an if statement starts with the keyword if. There's going to be something in parenthesis, and there's going to be something in between curly braces. So this is the expression to evaluate, and then here are the statements to run if the expression is true. Okay, so that's the general format. So let's just do an example. Var degrees equals, say, 36, and then we might say if degrees is less than 32, then we would say console.log it is cold, possibly snowy. Okay, so that would be that. If we run it, what do you think will happen? Degrees is 36. It's not less than 32, so this should not happen. Right, nothing gets printed. But then if we change degrees to be 31, we should see that. Let's go to a split screen. Okay, so I have my code here on top and then running it on the bottom. We can also have an else condition. Console.log, probably not snowing. Okay, so now with the else, which is optional, if we have the else, then we know exactly one of these two will run. Either degrees is less than 32, and then this will happen, or not, and this will happen. Okay, now if we change 31 to 36 again, we should see the else happen. Okay, and we can chain these together as well. Some languages have something called else if or elif. In JavaScript, it is just else if, so that we can chain these together. Let's say if it's less than 32, we get this. Otherwise, if degrees is less than, say, 50, we would say console.log, sorry about your luck, cold, and possibly cold rain. Okay, and then we can put as many of these as we want to. Otherwise, if degrees is less than, say, 90, 85, console.log, reasonable temperature. Congrats. And otherwise, we would say too hot. All right. So now with this chain, we have starts with an if. In between, we have else if, and at the end we have else. Exactly one of these will run. So first we try the first one. That's all these the order that it checks. So if the degrees is less than 32, it'll do this. Otherwise, it goes on to this one. So by logic, note that if we are here, then degrees is greater than or equal to 32. If the degrees was less than 32, we would never get to the point of evaluating this here, because we would have just done this part. Okay, and what do we know if we've gotten to this part? If we know that we got to this part, we know both of these failed, which means that degrees is greater than or equal to 50. That if we are here, we failed all of those. Degrees is greater or equal to 85. Okay, so which one did we get? We're 36, which is in between 32 and 50. All right. That is the basic structure of the if and else if, and in between here can be any expression that evaluates to true or false. And our options for building up things that are going to be true or false in our study guide, we have comparison operators, so less than or equal to, greater than or equal to. This exclamation equal is not equal to. This double equal is testing equality, is something equal to something else. And then this with 3 and not and then 2 equals is similar to these but more strict when you're comparing different types. And we have the Boolean operators, and, or, and not, which we'll see used soon. Let's go with if2. Let's take this and do it. So we'll do it without the else's. Let's say we want to have standalone if statements. Okay, so what would get printed if I run this right now? We want to pause and just do line by line. First you check this if. Is degrees less than 32? No. What happens next? We check this if. Is degrees less than 50? Yes. So we should print this. What happens next? We're done with this if. We would be right here. Do we check this yes or no? What is JavaScript going to do? In the first version, we had this else. If, else if, else if, else. It just evaluates these in order, and once it gets one, it's not going to do the rest. The way I have it here, it's going to do one after the other. So after I evaluate this and say yes, it is less than 50, I'll still evaluate this because it doesn't have an if else on it. And I'll still evaluate this. Let's say, I don't know. Let's just put true there for now. So we see sorry about your luck, that's this one, and then we see reasonable temperature, that's this one, and then we see too hot. If we want to make this correct, we would need to enforce both conditions. So if degrees is greater than or equal to 32 and then this would be if degrees is greater than or equal to 50 and this would be if degrees is greater than or equal to 85. We might want to say here and degrees as less than 150. Then we might have a separate one for if it's at least 150. Console.log temperature sensor malfunction. Alright, just to have something different. Take these comments out, they're no longer true because we don't have the else's. Alright, so this would give the same behavior as the other example. Now by logic, I've set up the conditions so that only one of them can be true. A question is, note this does the same as if.js, which is more efficient. Which involved less typing. So efficient is how long it takes the computer. The computer doesn't really care about how much typing I do. But if we look at this is the first version, what if degrees happens to be less than 32? So then we would go in here. If degrees happen to be less than 32, we would go here and then we don't have to check the rest of it. So that's good. We got to skip these other checks. What about this version? If degrees happens to be less than 32, we go here, but now we don't have the else's, so it's still going to check this, and it's going to check this, and it's going to check this, and the last one, and it's going to check this. Alright, so all of those ifs do need to get checked even though they don't end up being true. So the first one is more efficient, potentially. Let's look at them side by side and which one was less typing. Let's take a look at the second condition here. We have degrees is greater than or equal to 82 and degrees is less than 50, or else if degrees less than 50. So here we have 4 characters for the else versus this. So this one here was less typing and potentially more efficient because we skip out of tests we don't have to evaluate. So probably the better program, well, it depends on your depends on what you're looking for. Which one is more confusing? Depends on your experience. All right, that is if. Let's look at for next. So the basic structure for a for, there are a couple different ways. We're going to do this one first. Initialize. Semicolon. Check condition. Semicolon. Update. And then inside of here, statements. Alright, so the order of operations here is 1, we initialize, 2, we check the condition, 3, we run the statements, 4, we update, and then we go back to 2. So we initialize, check the condition, run the statements, update, check the condition, run the statements, update. Let's put an example in here. For the initializer, I'll say var x equals 1. Check the condition, I'll say x is less or equal to 10. For the update, I will say x equals x plus 1. And then the statements, console.log x. Alright, what do you think this will do? So we initialize. First we have x equals 1. And we check the condition. Is x less or equal to 10? Yes, it is. Then we go ahead and run the statements. Console.log x, which happens to be 1. Next, after the statements, we do the update. X equals x plus 1. Now x has the value 2. Check the conditions. Is 2 less than 10? Yes. Then we do the statements. So we keep running the statements, updating, checking the condition. Note the above is equivalent to initialize var x equals 1. Then we repeatedly do the following. Check the condition. If x is less or equal to 10. So it's like having an if test there. If it is, then we 3 run the statements. And do the update. So we keep doing this until we get to the point where this check fails. So that loop is just like if we had copy and pasted this over and over again, and it just keeps going ... until it is not the case that x is less or equal to 10. Okay, so if we want to do that without loops, we would have some 10 print statements. The way the for loop does it is like this. All right, let's do another example. For var x equals, say, 1, x is less than, say, 100, x plus equals 10. Let's start at 0. Okay, so this one will start at 0. We'll keep going as long as we're less than 100, and we'll add 10 each time. What will get printed? 0 up to 90, going up by 10. This plus equals is going up by 10. Let's do another one. I'm going to put a function in here. So this function is going to return true or false. True if it's prime, false if not. Okay, so if x is less than 2, we'll say it's not prime just as something. If x is 2, return true. There's the double equal. Otherwise, var n equals 3, n times n is less than or equal to x, n plus equals 2. So this is a prime test. I'm not too concerned about the details of how it works, but in the end, let's see, if x mod n is 0. Okay, so let's console.log is prime 5. So we can talk about how this works, but if it's correct, is prime 5 should be true. It is. If we put in 6, it should be false. So that's incorrect. Now it's correct. Let's put in another loop here. Var n equals 2, n is less than, say, 100. Let's say less or equal to 100. N plus plus. So there is a plus plus operator which just adds 1 to n. So let's just assume that is prime works right now. If is prime n, then we print n. So we run is prime, it's going to return true or false. If it happens to return true, then we're going to print it. And we start at 2, we keep going up to 100, we go up by 1. Okay, so those are the primes up to 100. Now, how does this actually work? We have the for loop. This for loop is just 2, 3, 4, 5 up to 100. Now we get inside, this n goes in here, so if x is 1 or 0, we're just considering it to not be prime. If x is 2, that's prime. If we happen to get here, what do we know? We know that we didn't return yet, because once you get to a return statement in a function, the function is done. You don't keep going. So if we did get here, we know that x is greater than 2. Because it's not less than 2 and it's not equal to 2. Now if it's greater than 2, what is this x mod 2? That is, you divide by 2 and take the remainder. If the remainder is 0, that means that x divided by 2 divides evenly. That means that x is even. So this here tests if x is even. It's a multiple of 2. Okay? Now we go down to here. So here we're testing if x is a multiple of n, for n starting at 3. And then it increases by 2 each time. 5, 7, 9, 11, etc. up to, it keeps going as long as n times n is less than x. Okay, what is that? Where does it stop? Suppose x is 100. Keep going, n keeps going as long as n times n is less than 100. For x equals 100 would go until n times n is greater than 100. Okay, so another way to say that is that we go up to roughly the square root of x. Here we go up to like 10, 9. In general, we go up to the square root of x. Alright, it's not difficult to show that this will work. So here we test multiple, is it a multiple of 3 or 5 or 7 or 9? We don't have to check the evens because we already checked if x is even. So we test all the odds. Is it a multiple of any of those? If it is, we return false. It's not prime. If it's not a multiple of any of those, it's prime. These are all the things that could be multiples. We only have to go up to the square root of x because if something is not prime, it'll have some factor that's at most the square root. Alright, so there's another for loop example, and you have your primes algorithm. Let's go to while. So while can do the same thing as for. Let's do, our first for example was var x equals 1. And we went as long as x is less than or equal to 10. And console.log x equals x plus 1. So this does the same as for.js, but with a while. So really, we can use either for or while. Either one can do the same thing. So this is our initialize. We haven't put our own statement for that. This is check the condition. We have some statements. We only have one there. And then we have our update. In general, the while, just the while part itself, you have while condition statements, and hopefully the statements change something related to the condition, otherwise you'll have an infinite loop. Infinite loop is something that never stops. So for example, while x is less or equal to 10, console.log x. This would be an infinite loop. We set x equal to 1, as long as x is less than 10, we print x. The rule of the while, so the order of operations for the while is you do the condition, you do the statements, then you check the condition. If it's still true, you do the statements. Check the condition. So you repeatedly check the condition and do the statements. So this is 1, 2, 2, and then we go back to 1. So the middle of the while loop is really one set of statements. Hopefully you're updating something related to the condition so that you don't have an infinite loop. That's a while loop. Let's go while 2. We'll do another example. Okay, so we'll do the conversion from decimal to binary. I'm going to create a string. So let's say I have some number equals, let's say, 45. The algorithm to convert decimal to binary. There's a JavaScript function that will do this for us, but we're going to go ahead and see how the code looks. So the algorithm was test if even, if yes, write a 1, otherwise a 0. Then we divide by 2, rounding down, and repeat. Okay, so let's just start with a if test. So if the number is even, then we would write a 0. So bin plus equals 0. We'll say it like this. Okay, otherwise, bin equals bin plus 1. So, and then at the end we'll have console.log num binary is bin. Okay, so right now we'll just get a 0 or 1, but let's just run it to see. There's an error. Forgot the plus. .45 in binary is 1, so that's just one of the bits. It's odd. I'll make a note on good programming. So good programming, write the smallest amount of code you can test and then test it. So for mine, I did this amount of code and then I tested it and I saw there was a problem and I already fixed it. You shouldn't write 100 lines of code and then start testing. You should do the smallest thing that you can test. Alright, so the algorithm is supposed to be divide by 2 and then round. So I would say bin equals bin divided by 2. And I want to round that down if it doesn't divide evenly. Let's see if this is right. Okay, so then I would want to repeat this. So I would say while bin is greater than 0, do this. Okay, so sorry, while num is greater than 0. Bin is going to be on my string of 1s and 0s. If the number is even, I put a 0. If the number is odd, I put a 1. And then I divide the number by 2 and round down. Keep going as long as I have something. At the end, I print bin. One zero one 101. Let's do about 8. So 8 in binary should be that. Okay, so it's in reverse order. I can actually reverse the order by doing this. I'm doing it this way. So the new bit, so I keep the bits that I already had because I'm really computing this bit first. So when I go to compute the next one, you can think about this for a second. Yeah, let's just see if it gives the right answer. Okay, so that will actually be correct. Let's see, what if we do 12? This is 1, 1. All right, so whatever we've computed already, we're adding on the next bit to the left here. And that is a while loop. And your quiz question. When in disgrace with fortune and men's eyes. That's from a Shakespeare sonnet. And it ends with, that then I scorn to change my state with kings. This is sonnet 29. So there's the first line, there's the last line. Type it exactly like this. So that'll be it. We had some basic examples of if, for, and while. So this is if, condition, statements. That was the version there, and the condition is a Boolean condition, something that can be true or false that you can build up with arithmetic, so with comparison operators and ands and ors and nots. The loops you had, let's do for loop, for initialize, some initializing things, some condition to check, and then an update that happens each time, and then you have statements. Basic syntax for a for loop, while, condition, statements. We probably should look at some syntax errors. So with the if we leave off these parentheses, let's just do it right here. Let's see what happens. We get an error, so that's away. If we leave off the semicolon or the curly braces, it's actually not a syntax error, but it's more likely to have errors in your code. So what the rule is for the statements is it's either a single statement or curly braces. And I'll show an example over in, let's see, for 2. For primes. So here in the primes, it's not a good example either. We'll stay here for a second. But so if we had multiple statements here, and we left off the curly braces, this will run. But what is this? What is the body of the for loop? So this is called the body of the loop. So what is the body of the loop? I'll let Emacs auto indent for me, and it's actually just this one statement. If you don't have the curly braces, it just does the single next statement. Even if you have your code indented like this, it doesn't care about your indenting. So it's more likely to have an error like this if you don't have the curly braces. So the curly braces, you're specifically saying those are the statements you want. Okay? We were in the if, so basically if you leave off the parenthesis or you have some syntax error inside of this expression. Let's say that I did something like this. There's no variable called n, so that's an error. If I leave off the 0, that's an error. In my for loop, the rule is that you have a statement here, a statement here, and a statement here. If I have another semicolon, that probably is going to be an error. It's expecting 2 semicolons, and the semicolons are there to separate these 3 statements. Statement 1, statement 2, statement 3. This one means initialize. That's what it's used for. This is a condition to check. This is an update. I could have syntax errors inside of any of those. If I don't have my parenthesis on my for loop, that would also be a syntax error. If I use curly braces instead of parenthesis, that'll be an error. Curly braces are used to group statements, not to specify a for loop. If I have square brackets, that'll also be an error. It has to be parenthesis. If I put quotes there, that would also be an error. And then for a while loop, this is my while loop, and here's one where if I left off my curly braces, this will run, but it will be incorrect. So let's auto indent. This will actually not run. Okay, it's actually an infinite loop. So this is what's happening. It does the while number is greater than 0. It does the next statement, which is an if, and it's else. So those go together. If and else go together. So it does this. Since I don't have the curly braces for the while loop, this is the one statement it will do, and then it will go and check num. But num hasn't changed. So it just keeps spinning there on the if test. So that's why I need to have my curly braces in. And I believe that this was noted in here somewhere. If you have an infinite looping program, I'll put a reminder for today, or I'll put a reminder here. Reminder to kill an infinite looping program in the terminal. Control C. So Control C. Okay, that'll be it for this one.